everyone, welcome to our lecture series on applied physics. This is Dr. S. Deepthi, Assistant Professor in Physics, Department of H&S, MLR Institute of Technology, Hyderabad. So, now, today, we are going to have a continuation of our lazy topic, which is Principle of Lasing Action, Metastable State and Population Inversion. So, in the previous video, we have gone through how lasers are going to occur and what are the characteristics of lasers. What do you mean by laser? These are the questions that we answered in our previous lecture. So today, let us recall about our previous lecture once again. That is, what is laser? Laser stands for light amplification by stimulated emission of radiation. So here, how stimulated emission occurs? Let us see through these three principles. One is principle of lasing action, and another one is metastable state, another one is population inversion. These are the three topics we are going to discuss today. So, coming to the principle of lasing action. The principle of lasing action is based on stimulated emission. So, let us recall about what is stimulated emission. Stimulated emission means whenever the atom rises from its ground state to the higher energy state. Let us consider a ground state like this. Let us consider a higher energy state like this. Then E1 is the ground state and E2 is the higher energy state. So, whenever the atom rises to an higher energy state, it is called as absorption, and that absorbed atom comes to the ground state after a while, and then if for that absorbed atom, if you provide some amount of energy h nu, then we are going to have the 2h nu. This is what we have already done in the previous lecture. Okay, see here, this is E1 ground state, this is E2 higher energy state, and whenever the atom is in the ground state, then the atom gets absorbed to the higher energy state and it will stay for a period of time and return to the ground state by giving some amount of energy called as h nu. If we provide some extra amount of energy h nu to that atom which is in the excited state, then another energy of h nu will also come, and this is known as stimulated emission of radiation. So based on this principle only, we are going to have the principle of lasing action. In stimulated emission, the emitted photon travel in the same direction as the incident photon. When these photons provide energy to the two excited atoms, then 4 are released as shown in the figure. See here in the figure, this is E1 is the energy lower energy state, E2 is the higher energy state, and if we provide energy to the single atom, then we are going to occur in a form of 2 atoms. And in the same way, these 4 photons can cause 4 stimulated emissions and 8 photons are emitted in the same fashion. In this way, a chain of reaction called as avalanche effect is produced. See here, whenever we are going to provide some amount of energy over here, then stimulated emission occurs where 2 photons are released. If we give the 2 photons to the 2 atoms, then we are going to get 4 photons and so on. This is known as avalanche effect or avalanche multiplication. So this phenomena is known as principle of lasing action or simply lasing action. So lasers are produced through this action itself. Next, coming to the simple definition known as metastable state, which is very important. So what is metastable state? So see here, we have ground state and we know that excited state. So both states we know as for. So the time of an atom that exists in the higher energy state is the time of the atom, is the lifetime of the atom. So what do you mean by lifetime? That means the staying capacity of an atom in the excited state is known as lifetime of the atom. Okay, the energy of an atom is the result of energy levels of individual electrons of that atom. So next, the energy of an atom consists of how the energy we are going to get. We are going to get the energy by providing some amount of external energy. Okay, some external energy is provided to the atom so that we are going to get the external energy, and this stays this feature enables the atom to stay in the excited state. So this is known as lifetime of an atom. And next, coming to the what is our metastable state. This is the existence of a state in such that it exists between ground state and excited state, such that the quantum state which is intermediate between ground state and excited state, where the atom stays for 10 to the power of minus 3 seconds. So this is the metastable state. This is very important to achieve the lasers. So we know that lasers are achieved by stimulated emission of radiation, but in order to get the more laser light, or in order to get our industrial use laser light, we can say, so we have to get the metastable state. We have to use the metastable state. Okay, this is about metastable state. Now, how this occurs, how the laser action occurs? Now, by having the important thing known as population inversion. Population means the number of atoms that exists in the ground state or excited state or metastable state. This is known as population. Number of atoms are known as population. Okay. Now, if the number of atoms is more in the higher energy level than the number of atoms in the lower energy level, then it is known as population inversion, which is from the definition. So, generally, the number of, as we can see in the figure, see here in the figure, the number of, if we draw a graph in between number of atoms and energy level, always the number of atoms in the higher energy state will be more. Okay, so the number of atoms in the higher energy state is more compared to the in the ground state is more compared to the higher energy states. So the number of atoms will be more in the ground state compared to the higher energy states. This is the order. So now we want to achieve, we want to inverse that one. Inversion means we want to rechange that one. So in order to rechange that one, as shown in the figure, if the number of atoms in the metastable state, second state known as metastable state as we know, so if the number of atoms in the metastable state are more, if we achieve the more number of atoms in the metastable state than the ground state, then which is known as population inversion. Okay, the condition N2 is greater than N1 is called as population inversion. Okay, this is about our population inversion, which is very useful in order to get the laser light. Thank you.